Good evening, children.
Good evening, ma'am.
Yeah, good evening. I've shared my screen. It's visible?
Yes, ma'am.
Ma'am.
All right. Very good. Okay, so last class we started with volumes and surface areas, and we had a good introduction to all the formulae in this chapter. All right, those who missed it should have used the meeting recording. Oh, I think I did not share it. Sorry. All right, so those who missed it, I don't know, must have at least learned it in school. Otherwise, I'll share the recording today. You can have a look at the introduction. Now we are continuing with the chapter. These are extra problems from volumes and surface areas. So this is the first one. See the question. The radii of two right circular cylinders, the radii of two right circular cylinders are in the ratio 2:3. And their heights are in the ratio 5:4. Calculate the ratio of their curved surface areas. Madhumita, what's the formula to find the CSA of a cylinder? What's the formula to find the CSA of a cylinder?
2 pi RH, ma'am.
CSA of cylinder is equal to 2 pi RH. Danya, what's the formula to find the volume of a cylinder?
Pi R square H, ma'am.
Pi R square H. Very good. All right. So here we have two right circular cylinders. We have two cylinders. Okay. And the ratio of their heights and radius is given to you. So that means R1 is to R2 is equal to 2:3, correct? And H1 is to H2. H1 is to H2 is equal to 5:4. You can see there the ratio of their radii 2:3. Ratio of their heights 5:4. So with this given to us, we need to find the ratio of their CSAs, curved surface areas. The ratio of the radius is given to us. R1 by R2 is given to us. H1 by H2. The ratio of their heights is given to us. We need to find the ratio of their curved surface area. That is curved surface area of the first cylinder by the curved surface area of the second cylinder. This is what we'll have to find. We'll have to find the CSA, the curved surface area of the first cylinder by the curved surface area of the second cylinder. Ratio we have to find. To see the answer, I'll tell you children to start writing. First listen to me, then you can write. I'll give you time to write. So now see here, let the radius of the two cylinders be 2x and 3x respectively. Correct? And let the height of the two cylinders be 5y and 4y respectively. So radius of one cylinder 2x, other cylinder 3x. Height of one cylinder 5y and the height of the other cylinder 4y. Now what is that we have to find? CSA1 by CSA2. The curved surface area of one cylinder by the CSA of the other cylinder. So what's the formula? 2 pi RH by 2 pi RH. We have to find this. But you cannot say 2 pi RH by 2 pi RH. So it will be 2 pi R1 H1 by 2 pi R2 H2. 2 pi RH is the formula to find the CSA of a cylinder. 2 pi RH is the formula to find the volume of, the curved surface area of a cylinder. Now we are comparing the curved surface areas of two cylinders. So it will be 2 pi R1 H1 by 2 pi R2 H2. Now substitute. 2 pi and 2 pi will get cancelled in the numerator and denominator. All right. So see 2 pi and pi will get cancelled. So now what is R1? What is R1? 2x. What is H1? 5y. See here. You can see it here. 2x and 5y. And what is R2? R2? 3x. And H2 is 4y. So substitute. Again, x and x will get cancelled. Y and y gets cancelled. You can simplify. 2 1s are 2 2s are. Correct. So on simplifying, you get the ratio as 5/6. So the required ratio is 5/6. Right on, children? So, yeah. Done writing, children? Online students, finish writing?
1 minute, ma'am.
Yes, ma'am.
Okay,
Completed, ma'am.
right.
Completed, ma'am.
Right. So see, you don't have to say pi 1 and pi 2. Pi is a constant. R1 and R2, they are different for different cylinders. You don't have to say 2 pi 1 R1 H1 because pi is a constant. The value of pi is 22/7. So you don't have to say pi 1 and pi 2. 2 is a constant, pi is a constant. So for constants, you don't have to say 2 1 and 2 2. 2 and pi are constants. So only for R and H, R1 H1, R2 H2. So the ratio of their curved surface areas is 5:6. The volume of a metallic cylindrical pipe is 748 centimeter cubed. See, when we say it's a pipe, it's a hollow cylinder. When it's given, it's a pipe, it's a hollow cylinder. Pipe meaning hollow cylinder. Yeah, see, I'll try to draw. I'll try my best. Or I'll show you the introduction image. I was telling you that bring the sellotape, no, sorry. Yeah, see here. A hollow pipe is something like this. See, this is a hollow pipe or a hollow cylinder. This one is a hollow pipe or a hollow cylinder. Why is it hollow? Because see, I can see the ends are open. The circular ends are open, so it's hollow. And when we say cylindrical pipe, pipe itself is something like this, but it will not be, may not be so wide. It will be narrow. The opening will be narrow. But this is what is a cylindrical, because it's cylindrical in shape. Cylindrical and pipe. When it's pipe, it's like this. And see here, there's some thickness. The wall of the pipe is thick. The wall of the pipe, see, this is the wall of the pipe, and it's thick. You can see two circles. You can see two circles. One inner circle and one outer circle. Correct? You can see two circles. You can see two circles. The two circles will have the same center, but different radii. So there's something called small r and capital R, because you can see two different circles. Because you can see two different circles, you have two different radii. The inner radius, for the inner circle, the radius will be small. For the outer circle, the radius will be bigger. So small r for the inner circle, capital R for the outer circle. And the height is the same. There is nothing like inner height and outer height. Only radius we have, inner radius and outer radius. Height is only one height. Or we can also say the thickness of the cylinder. Sometimes the height is given as the thickness. Sometimes the height is given as the thickness of the cylinder. Now, in case of a coin, in case of a 5 rupee coin, a 5 rupee coin is not a circle, it's a cylinder. It's a cylinder wherein the thickness is not too much. It's kind of half a centimeter or maybe even less than that. A coin, a 5 rupee coin, is a cylinder. It's a solid cylinder. It's a solid cylinder. It has only one radius because there's only one circle on the top. The coin has only one circle on the top, so only one radius. And the thickness of the coin is the height of the cylinder. A 5 rupee coin is not a circle, it is a cylinder. The circular ends, they are closed. So it's a solid cylinder. It's full of metal, that coin. So it's a solid cylinder. And there's only one circle. Of course, there are two circles, top and bottom. But they'll have the same radius R. So there's only one radius R. And the thickness of the coin is the height of the cylinder. So if you have to find the volume of a coin, a 5 rupee coin, say it is pi R square H. Pi R square H. Volume of a cylinder is pi R square H. But this pipe is a hollow cylinder. So what are the values you have for a hollow cylinder? Inner radius, small r, outer radius, capital R, and one height, small h, just one height, small h. No two different heights. And this thickness is called W, is represented by the letter W. The thickness is represented by the letter W. So you can understand the inner radius plus the thickness is the outer radius. The inner radius plus the thickness will be the outer radius. The inner radius from the center to the inner wall is the inner radius plus this thickness will be the outer radius. So whenever it's a pipe, it's a hollow cylinder. It's open at both the ends. A pipe is open at both the ends. The wall may be thick or thin. That depends on, how the question reads. The wall may be thick or thin. That depends on the question. You'll have to read the question and understand that. Okay, now let's go back to the question. Now see here, I can see something like, look at the question, how it's given. The volume of a metallic cylindrical pipe is given to you, 748 centimeter cubed. Its length is 14 centimeter. That means the height. Length meaning the height is 14 centimeters. So height is given, the height is mentioned using different words. Length meaning the height of the cylinder is 14 centimeters. And it's external radius. Why should they say external radius? Tell me. Why external radius? That means there is an internal radius. Why should they use the word external radius? That means there's an internal radius. That means the wall is thick. It's a pipe like this, wherein the material is thick. The material with which the pipe is made of, the material, the wall is thick. That's why it has two radius. There are two circles, and so one small r and one capital R. The external radius, that is the value of capital R. The value of capital R is 9. You need to find the thickness, that is, you should find W. How will you find the thickness? You should find the value of small r. Once you find small r, capital R minus small r is the thickness. See here, outer radius minus the inner radius will give you the thickness. The outer radius minus the inner radius will give you the thickness of the pipe. Supposing the inner radius is 5, the outer radius is 8. That means 8 minus 5, 3 is the thickness of the wall. Supposing outer radius is 8, the inner radius is 5. So 8 minus 5, 3 is the thickness of the wall. So how can we find the thickness? We'll find the inner radius. Once you find the inner radius, you can find the thickness. Simply substitute in the formula. That's all. See, how do we do this? Just the first equation you have to write is very important. See, the very first equation, you just have to say volume of the pipe. Okay, so you can write that in detail when you write the answer. So volume of pipe is equal to 748 centimeter cube. If you can write this, you will get the answer. Can we all write this? It's given in the question, right? Volume is 748 is given to us in the question. So it's easy to write this. Now, what is the formula to find the volume? Listen to me carefully. It's a cylinder. So what's the formula? Pi. Normally it is pi r square h. Pi r square h. Now here it will be, it's a pipe, no? So it will be pi r square minus r square into h. Remember like that. It's normally for a cylinder, it is pi r square h. Here it will be pi r square minus r square into h. This is the formula to find the volume. Is equal to 748. This is also easy to write. Now next step. Pi is 22 by 7. The value of capital R is 9. So 9 square. 9 square. All right. External radius is 9. 9 square minus r square. We don't know. Into h. That's only the length. 14 is equal to 748. Now, what do we see or what do we understand from this? In this equation, there is only one unknown r. In this equation, there's only one unknown r. So we can easily find, since 8th standard, we've been solving equations to find x, to find the value of x. So like that, you'll have to solve this and find the value of r. See, in this equation, there's only one unknown r. So it's easy. You can solve and find the value of r. That's all it is. Right on, children? Any questions you can ask me first, write down. See, I've written, anyways, you can write, see, I've written pi h into r square minus r square. Both are the same. I said pi r square minus r square into h. Everything is the same. You can write it that way also. You can also write this as, this is not wrong. You can also write it as, I have to change everything then. This is also fine. You can put the h here also, children. It's multiplication, no? So anywhere you can put it. Done, children?
Yes, ma'am.
Yes, ma'am.
Srijana, Sindhu and Sanjay?
Yes, ma'am.
All right. So I'll just tell you how it's worked. You might have understood, but just tell you. So first volume formula we write pi h r square minus r square is equal to 748. Then the value of pi is 22/7. Height is 14. Capital R 9. 9 square minus this we have to find is equal to 748. Now 7 ones are 7 twos are. All right. 7 ones are 7 twos are. See here? After substituting 7 1 the 7 2. See, all this I can't show when I type, you know. This cancelling I cannot show when I type. So but you should run it in your book. 7 1 the 7 2s are. Now this is 22 into 2, 44. What will happen to this 44? It will come down to the other side for division. This 44 comes to the other side for division. So 748 by 44. And here 9 square is 81 minus r square. And when you divide 748 by 44, the quotient is 17. When you divide, 44 and 748, or you can even cancel. You get 17 as the quotient. So now transpose. You'll have to find r, no? So you will get minus r square is equal to 17 minus 81. So minus r square is equal to minus 64. Minus and minus will get cancelled. So many steps you don't have to show. So directly r square is equal to 60. You can write all this. You can write all this. So r square is equal to 64. R is equal to plus or minus 8 actually. But minus 8 is not possible, no, because the radius cannot be negative. The radius cannot be negative. So r is plus 8. See, you can show the steps in between, children. Here you can show minus r square is equal to 17 minus 81. Minus r square is equal to minus 64. So minus gets cancelled on both the sides. R square is equal to 64. So you can show all this. So r is plus or minus 8, but minus 8 is not possible because it cannot represent the radius of a circle. It cannot be negative. So leave that. So r is equal to plus 8. So what is the value of small r? 8. So now see here. This is the outer circle. This is the inner circle. From here to here, the radius is 8. Okay, from the center to the inner circle is 8. And from the center to the outer circle, this one, till here, from the center to the outer circle is 9. From here to here is 9. But from here to here is 8. That means the difference is 1. No, the thickness is 1. The thickness is 1. So capital R minus small r. 9 minus 8. 1 is the thickness of the material, that metal, whatever metal it is. Is it easy, children? Offline students also? Any questions?
No doubts, ma'am.
No doubt.
All right, children, fine. See this one. The cost of painting. The cost of painting the total outside surface of a closed cylindrical oil tank. So we need to understand what kind of solid it is. It's a closed cylindrical oil tank. So it's cylindrical in shape. The solid is a cylinder. It's closed. It's a tank. No, obviously it has to be closed. It can't be a pipe. It has to hold the oil. So it'll be closed at the bottom. But whether it is closed on the top, that the question should tell you. It's a tank, oil tank, mostly it's closed. It's also given in the question that it's see, when it's an oil tank or a tumbler is closed at the bottom. A tumbler is open at the top. That's understood. No meaning, see, a tumbler, when we say, doesn't come with a lid. Maybe there is, but normally when we say tumbler, it doesn't come with a lid. When we say a tumbler or a glass tumbler which looks like a cylinder, there's no, it's open at the top. It's closed at the bottom. Okay, so from the words, you should be able to understand, how the solid looks like. Is my voice clear, children? Tanya, Sindhu, Sanjay, Madhumita, Srijana.
Yes,
Yes,
ma'am.
ma'am.
Okay. Yeah, the cost of painting the total outside surface of a closed cylindrical oil tank at 60 paise per square decimeter is rupees 237.60. The height of the tank is 6 times the radius of the base of the tank. Find its volume correct to 2 decimal places. Okay, now you need to, now in general, when you buy something, supposing I always say, like, you buy some fruits, okay, for rupees 480. You buy fruit for rupees 480, and the fruit seller sells it to you for at rupees 60 per kg. 60 per kg. Now, how will we write the equation for this? Cost per kg into the number of kgs purchased. Number of kgs purchased is equal to the total cost. How will you find the total cost? The total cost will be, the fruit seller says 60 rupees per kg. Then you decide, how many members are there in your family, and or maybe you're getting guests, you have to buy more fruits. So you decide to buy 8 kgs, right? 6 8 are 48. So the fruit seller will not say take 8 kgs. The fruit seller will only tell you the rate per kg. He'll say whatever fruit is 60 rupees per kg. You have decided to buy 8 kgs. And so your total cost is 60 into 8, 480 rupees. So that means the cost per kg is 60 rupees. And you have decided to buy 8 kgs. So your total cost is rupees 480. In the same way, so you remember this rate. This is the rate. This is called the rate actually. This is the rate. This is the cost. This is the cost. The 60 rupees is the rate. It's actually the rate per kg. And this is your total cost. This is your total cost. In the same way, here, see the equation I write here. The total surface area of the cylinder into the rate per square decimeter is equal to the total cost. Is equal to the total cost. See, forget it now. Don't get scared in decimeter. We'll convert it later to centimeter or whatever. Now you can work with decimeter. Now the painter, okay, the painter tells you that for every square decimeter, for that area, for every square decimeter, you will have to pay him 60 paise. That's what the painter can tell you. The painter can only tell you that for every square decimeter. So you have the cylindrical tank. You have the cylindrical tank. You want to paint it all over on the outside. You have a cylindrical tank and you want to paint it. Are you all listening, online students? Or you're trying the answer? Please listen. Don't write. Are we all listening? Say yes.
Yes, ma'am. Yes, ma'am.
Others? I got only 2 responses. Others?
Ma'am.
Okay. So the painter will only tell you the rate per square decimeter. He'll say to paint 1 square decimeter, pay me 60 paise. Now, how will you find how much you have to spend? How will you find the total cost? So you will find the total surface area of the cylinder. Why total surface area? Why not volume? Because you're not pouring in anything inside this. Volume is something to do with the capacity inside of the cylinder. Volume means if you're filling something inside the cylinder, you're painting the surface, right? So surface area. You're paint. See, when it is when we talk about solids, we can find 2 things: volume or area. It will be either volume into rate or surface area into rate. That's all it can be. It can be volume into rate or surface area into rate. Now, why is it surface area here? Because you're painting the surface area. And which surface you're painting? All over on the outside. That means the total surface area of painting. The top circle, the bottom circle, and the curved surface area. The top circle, the bottom circle, and the curved surface area. It's a cylinder. You're painting all this. For 1 square decimeter, 60 paise. So the total surface area of the cylinder, this much area you're painting. You're painting this area. So the total surface area of the cylinder into the rate will be your total cost. See, just imagine your tank has an area of some 50 decimeter square. Supposing your tank has an area of 50 decimeter square. So you'll have 1 decimeter square, 60 paise. So for 50 decimeter square, it will be 50 into 60 paise. That will be the total cost. That will be your total cost. 1 decimeter square, the painter says 60 paise. You computed, okay, the total surface area of your tank, and you got 50 decimeter square. So now you can calculate 1 decimeter square, 60 paise. So for 50 decimeter square, you'll spend 50 into 60 paise. 50 decimeter square into 60 paise. So much paise you have to spend. That is what I've written here. You should not write volume. You're not doing anything inside the cylinder. So the equation is this. So always, in volumes and surface areas, read the question and write the first equation. That's all. If you can write that correctly, you will get the answer. See here, what was the first equation? You just have to write volume is equal to 748. That's all. Then below that, volume formula is equal to 748. Below that, substitute the values. And you find the value of R. Same thing here. Just write that first equation. What do you understand? What equation can you construct from this? The total surface area of the cylinder into the rate per square decimeter or decimeter square will be the total cost. This is the equation. This is the equation. Now, what is the total surface area of the cylinder? 2 pi r into r plus h. This is the formula. 2 pi r into r plus h is the formula to find the total surface area of the cylinder into the rate. Into 60 paise, but you want to convert it to rupees, right? So you can write 60 by 100 here. That means you've converted to rupees. Or you can write 60 paise also. But the thing is, here the total cost is given in rupees. See there on the other side. The total cost is given in rupees. So you have to change this to rupees. In one equation, you can have only, meaning the units must be the same. The units must be the same. So 60 paise is 60 by 100 is equal to the total cost, 2 rupees 237.60. All right. 2 pi r into r plus h into the rate, rupees 60 by 100. You're converting paise to rupees is equal to the total cost. Now substitute, or you can even calculate this, instead of substituting, you can just calculate this first. 2 pi r into r plus h is into what is this? 23s are 25s are correct. 3 by 5 becomes. So on the other side, okay, let me write 3 by 5 is equal to, you can convert this also to fraction. The 0 has no meaning, right? So it will be by 10. Just take away the 0. That 0 has no value, just take it away. So 0.6. So you can remove the decimal point and write by 10, converting the decimal to a fraction. Now 2 pi r into r plus h is equal to 2376 by 10 into 5 by 3 into 5 by 3. So this is 5 ones are 5 twos are, then 2 ones are 2 1 1 8 are 16 8 are 16. Then I think 8 8 16 17. Yeah, this is also divisible. 3 ones are 3 threes are 9. 3 nines are 27, 3 6 are 18, 396. So see the total surface area we found out. It's 396 here. 2 pi r into r plus h is 396 decimeter square. Decimeter square. So we found the TSA 396. Have I worked it here? Luckily, I've done this. Okay. All right. Now, what did you find? 2 pi r into r plus h is 396. 2 pi r into r plus h is equal to 296. 396. Okay, so 2 into 22 by 7 into what is given? The height is 6 times the radius. So if the radius is r, the height is 6r is equal to 396, correct? The height is 6 times the radius. So radius is r. The height is 6r. Now see, we have one equation in which we have only one unknown r. So you can solve this and find the value of r. So what will be 2 into 22 by 7 into r. R plus 6r is 7r. So into 7r is equal to 396. So then the 7 and 7 gets cancelled. R square. So you know how to calculate. That's all it is. Start writing, children. Calculation, please do it by yourself. Take down only till here, children. Don't write this. Do it yourself. This part you don't write from here. After this, you continue. Because you can cancel 7 and 7. I have not done that. You can cancel 7 and 7. Please simplify by yourself after writing till here. No, there's nothing here. Okay, let me help you to simplify this one. So I should have cancelled the 7 and 7 here itself, children. Okay. So on the other side, you'll get r square is equal to 2376 by 10. 3 by 5 comes as 5 by 3. And this 44 will come for division. So just, okay, even if you get 7 here, they'll get cancelled now. Now, 5 ones are 5 twos are. Now, whenever you have 44 and things like this in the denominator, no, try 11, tables of 11. Because 44 is divisible by 11, right? So try by 11. So 11 fours are 44, 11 twos are 22, 1 remains, 11 ones are 11, 6 remains, 11 six are 66. Mostly it will be divisible by 11. You should try. So it's divisible now. Then 2 ones are 2, 1 not 8 times. And 4 ones are 4, 4 twos are 8. Correct? 2, 4, 7 are 28. Now 27 by 3. So 3 ones are 3 nines. So r square is equal to 9. You should divide 44 and 2, 3. You should divide 2, 3, 7, 6 and 44 by 11. By the tables of 11. 11 fours are and 11 216 times. So all of you should get 9. On simplifying, r square is equal to 9. R is equal to 3. So r is 3 meaning the radius is 3. The radius of the cylinder is 3. And what is height? 6 times r. So 6 into 3. Height is 6 times the radius. So 6 into 3, 18 decimeter. Now the question is to find the volume. Volume is equal to pi r square h. So 22 by 7 into r square. R square is 3. So meaning r is 3. So 3 square into h, 18. Yeah, and that is up to 2 decimal places, 509.14 decimeter cubed. They have not asked you to convert it to centimeter cube or meter cube, so leave it like that. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. All right. So without looking into your books, tell me the equation. What is the equation? Total surface area of the cylinder into the rate is equal to the total cost. Because see, now the thing is, how do you know that we have to write it? These are the quantities, spoken about in the question. See, we have the rate here, 60 paise per square decimeter. We have the total cost, 237.60. And what is painted? Why are you incurring this total cost? Because you're painting the body of the cylinder. There is rate here, there is total cost there. And why are you spending that money? For what work are you spending that money? Because you're painting the total outer surface of the cylinder. And what is that outer surface? Total surface area. What's the formula? 2 pi r into r plus h. See, if the question talks about time, distance, and speed, you will write speed is equal to distance by time. If the question talks about speed, distance, and time, then you will write speed is equal to distance by time. Now here the question talks about rate, total cost, and the the total surface area. So how will you connect these three quantities in an equation? How will you connect these three quantities in an equation? This is what it is. You should write this. You must write this one. Now 2 pi r into r plus h into the rate, which is 60 paise or 60 by 100 to convert it to rupees, is equal to the total cost, 237.6. So you can just write it by 10. 237.6, you can ignore the 0. To convert this to a fraction, 2376 by 10. This is in rupees. This is also in rupees now. And what is R? R is R only. What is H? 6 times R. Just have to substitute all this and you will find the value of R. Once you find R, H is equal to 6 times R. Now you know the radius and height. Find the volume, pi R square H. Because to find the volume, you need R and H. To find volume, you need R and H. Now we found R and H. Put it in this formula and find the volume. The curved surface area and the volume of a pillar are given to you. Find the diameter and the height of the pillar. So again, nothing is mentioned. So it's a cylindrical pillar. Nothing is mentioned. See, the pillar can also be cuboidal, but you can see the word diameter there. The pillar can also be cuboidal. In your school, you will not, I don't think you can find cylindrical pillars. Cylindrical pillars are mostly in temples. Mostly, we don't find them outside. Or maybe the flyovers, I think at the bottom, they may have cylindrical pillars. But mostly in your schools, if at all there's a pillar, it's cuboidal. It's cuboidal. Pillars can be cuboidal or cylindrical. You cannot find conical pillars. Very rare. If the pillar is conical, it will be given to you. We can assume only two things. See now that pillar, it's cuboidal. It's a cuboid. That's a cuboidal pillar. So pillars in general are cuboidal or cylindrical. Now how do you make out? It's not given here. How do you make out? See, the word diameter is used. When will they use the word diameter? Only if it is a cylindrical pillar. Only if it is a cylindrical pillar. That's why a diameter is given. So the curved surface area and the volume of the pillar is given to you. You should find the diameter and height. So you can do it in many ways. The easiest, I think, can be this one. You can just divide one by the other. See, when you have two things, you can add. See, now when I have, listen to these ideas, children. Class, use the emoji, raise your hand. Madhumita, Danya, Srijana, Sindhu, and Sanjay. Very good. Now, when we have two equations, you can add them. See, now I have two equations. A is equal to 5, B is equal to 7. Now, what can I do with them? I can add them. A plus B is equal to 5 plus 7, which is 12. All right. Now you can subtract them. A is equal to 5. No, are you following? Can you see the screen clearly? Yeah. So you can subtract them. You can subtract them. So you can do A minus B is equal to 5 minus 7. So A minus B is equal to minus 2. You can subtract them. You can multiply them. A is equal to 5, B is equal to 7. You can multiply them. 1 minute. What do you get when you multiply the two equations quickly? What's your name? Arjun. What is 35? Multiply both the sides.
A is equal to 5 into 7.
Yeah, AB is equal to 35. What do you get when you divide them? When you divide, what you get?
A is equal to A by B is equal to 5 by 7.
Very good, very good. A by B is equal to 5 by 7. So when you have two equations, you can do it. You can add, you can subtract, you can multiply, you can do anything, you can divide. Now we have two equations like this. We have two equations here. CSA is equal to 264. Is one equation like A is equal to 264. And volume is equal to 396. Like B is equal to 7 or B is equal to 396. Now you can divide these two. There are two equations. Now you can divide them. So you can divide CSA by volume. So CSA by volume is equal to 264 by 396. What is CSA formula? It's a cylinder. 2 pi RH by volume pi R square H is equal to 264 by 396. Now H and H will get cancelled because it's the same cylinder. It's only one pillar. It's not two different pillars. It's not R1, H1 and all that here because it's the same pillar. So radius and height is the same for the same pillar. All right. So H gets cancelled, pi gets cancelled, and there is one R here and one R square here. So one R. So what is remaining? 2 by R is equal to, you can cancel this also. And you can solve this and find the value of R. You can solve this and find the value of R. And once you find R, double it to get the diameter. Then we'll have to find the height of the pillar. So use this formula. 2 pi RH. What is 2 pi RH? 264. Okay, so 2 into 22 by 7 into R we just found, no? We would have found R. Put that value into H is equal to 264. Solve this and find the value of H. Solve this one and find the value of H. So here what we're doing is when we have these two equations, we're dividing one by the other. Right on, children? Take your time. There is no hurry. Please understand and write.
Completed, ma'am.
Yeah, good. Arjun finished? Arjun, how do you simplify this? Tell me. 264 by 396.
64 and 396 cancels by 3 as 88 and 132.
388 times, and this is 132. Okay, then 4. Don't remember what you did? Why you didn't cancel at all? I just canceled it. Should do that. If you don't want to do with the pen, at least with the pencil, you should simplify. Tables of 34,
132 cancel with
by 4. Okay, so 4 3s are 12. 4 3s are. You got 33? What did you do, Raja? No, you should not. You should have cancelled. You just wrote 264 by 396 and left it, is it? No, you should simplify it. I'm telling you, no, I can't do it.
88 is 22.
Tell me again, 264, how many times?
264 is 88 times.
By?
And 396 is 132.
Okay, then?
Then 88 is, when 88 is divided by 4, we get 22.
Mm.
132, we get 33.
33, okay, then?
Then by 11 table, we can cancel it as 2 times.
Very good, yeah. You should do the simplification. All right. How many cubic meters? So that means they're asking you to find the volume. How many cubic meters? That means volume. How many cubic meters? Because meter cube. Cubic meters meaning meter cube. Meter cube. Okay. How many cubic meters of earth must be dug? Must be dug to sink a well. To sink a well meaning to dig a well. Okay. The depth of the well is 14 meters. And the radius of the mouth of the well, it's a cylindrical well. Okay, it's a cylindrical well. The depth should be 14 meters. And the mouth of the well, which is circular, should have a radius of 4 meters. So they're asking you how much earth should be dug out. That means you just find the volume. Because digging out, no, it's volume. It's on surface area. Some volume of earth is removed. Some volume. Okay, 1 kgs, 2 kgs, kg is volume. So you're not finding in kilograms here. You're finding in meter cube because you have the radius and height in meters. So how many cubic meters, meaning what volume of earth must be dug out to get a well 14 meters deep and of radius 4 meters? That is one question that can be answered because you know that the radius is 4 meters and you know the height is 14. Oh, sorry, 14. So the formula to find the volume is pi r square h. R is 4 and h is 14. So you can find the volume. Okay, so first answer we know. If the earth taken out, some earth is removed, right? When you dig the well, earth is removed. When the earth removed is spread over a plot. Okay, so the earth is not wasted. The mud which is taken out is not wasted. It is spread over a plot. 25 meters by 16 meters. The dimension of the plot. See, the plot is actually the surface of the plot is rectangular. If it's a field, you know, listen to me, if it's a field, the surface is a rectangle. Now, if you dump some sand on it and you create a platform, if you create a rectangular platform, that is a cuboid. The platform is a cuboid. Now, children can see there in the class. The floor is a rectangle. The top, the surface of the floor is a rectangle. Now, I have created a cuboid there. The dais is a cuboid, but the floor is a rectangle. The surface of the floor is a rectangle. Now, when you dump, when you dump the earth, it becomes a cuboid. See, actually, first you have a plot. The plot is rectangular, 25 meters in length and 16 meters breadth. The plot is rectangular. Now, when you dump the earth on it, meaning the earth has a height now. When you dump it, there is some height now. So the plot becomes a cuboid. Because when you dump earth, there is some height now. Earlier it was 2-dimensional, only length and breadth. Now when you dump earth on it, there is height also. So now it's cuboid. What is the height of the platform so formed is a question. A platform is formed of length 25 meters, breadth 16 meters. What is the height of the platform? Why is the length and breadth 25 and 16? Because on the plot only you're dumping the earth. So the length and the breadth of the platform will be 25 and 16. But what is the height? That's what you'll have to find. Now here again, what is the equation? The equation is the volume of the earth removed from the well. It's enough if you write the equation in words. Then we'll convert it to a mathematical equation. First, you should write the equation in words. What is the equation in words? Whatever we just understand, the volume of the earth removed from the well is equal to the volume of the earth in the platform. Because from there you're removing and you're dumping it here. So the volume of the earth which is removed from the well will be equal to the volume of the earth in the platform because you've not wasted anything. From the earth, from the well, you took the mud and you dumped it on the platform. So the volume will be the same. Like if you've removed 100 kg of earth, that 100 kg of earth is now in the platform. From the earth, from the well, if you've removed 100 kgs of earth, that 100 kgs is now in the platform. So the volume is the same. That is the equation which you have to write. If you can write that, you will get the answer. So you should just write this. Well, what you have to find is the height of the platform. Okay, so I'll write that platform first. You can write anything first. Let me just write volume of earth. Volume of earth in the platform. The volume of the earth in the platform is equal to the volume of the earth removed from the well. Earth removed from the well. Are you listening, Tanishka? Volume of the earth in the platform is equal to the volume of the earth removed from the well. Is this equation correct, children? Am I right? Yeah?
Yes, ma'am.
Your children agree with me? Whatever earth you have removed from the well, it's now in the platform. Earth meaning what? The mud. Okay, so how will you find the volume of the earth in the platform? LBH, because it's a cuboid. How will you find the volume? LBH, length into breadth into height. And how will you find the volume of the earth removed from the well? Pi r square h. It's a cylinder, no? Pi r square h. Or you've already found it here. You'd have already found in the first part of the question, you have to find how much of earth is removed. You have the answer there. But supposing that question was asked, not asked, then it will be pi r square h. You should put h1 because there is h here also. There's h here also, no? So you should not put h here. This is the height of the platform. This is the height of the well. They are different. So you can even say h1 and h2. Nothing like this only should be h and that only should be h1. Nothing like that. Just differentiate. You can even use a small h and a capital H. Because the height of the well is, more. So you can even use a capital H here. See, that's your choice. You can say h1, h2, whatever. All right. Now, what is this? Volume of the earth in the platform. What is this? Volume of the earth removed from the well. This is cuboidal. Sorry, this is cylindrical. So now what's the length? 25 into the breadth of 16 into height we don't know is equal to 22 by 7 into r square. What is the radius? 4 into 4. This is of the well. This is of the well. This is of the platform. Radius of the well is given there 4 into the height for r square. So 4 into 4 into height, which is 14. That's all. See here, h is only alone, meaning h is only unknown. You can solve this and find the value of h. So it's always important to write the equation. What you understood after reading the question, that equation you must write. So the equation in words, in English you have to write, not even in mathematical language straight away. Just in English, whatever a layman can understand. So all of us understand whatever earth is removed from the well is now in the platform. All of us understand that. So that you write first and then use the formula. So this is what you do when this question is not asked. Here you found the, if this is not asked, how many cubic meters of earth should be dug out? Here we have to find the volume, right? So we have already found the volume. So maybe we'll use that value straight away here. But I hope you understand what I'm trying to say. Let's see the answer. Yeah, so that's what I was telling you here. This we already found here. So the volume of the earth, see here. Volume of the earth dug out is pi r square h. So that's 704. So what is the volume of the earth spread over the plot? That is 704. Whatever is removed from the well is now spread here. So what is the volume of the earth spread over the plot? 704. How do you find the volume? See, this is the left-hand side. This is the right-hand side. Right-hand side, write it down as it is because it's a number. Right-hand side, write it as it is. It's a number. This is equal to, you put it as it is. Now this one you should convert to maths formula. Volume of the earth in the plot. Volume of the earth in the plot is LBH. Why LBH? Because it's a cuboid. It's a cuboid. So volume is LBH. And you will not use H here because you already have H here. So H1. H1. That's all. Find H1 from this. And that's the height of the platform. Write down, children.
Completed, ma'am.
Yeah, all right, children, just a minute. Yeah, any questions, online children?
No doubts, ma'am.
No doubts, ma'am.
All right, children. Look at this one. Oh no, this we need to work a little more sums to understand this. So I'll not do this now. Yeah. Yeah. Look at this one. The sum of the radius. You can just write down this question. Please make a note of this question because then I might forget to teach you. Just make a note of this question, children.
Yes, ma'am.
All right. Okay, maybe I'll see if I can make you Understand? Let me do it. All right. So I've tried to represent a cylindrical vessel. Okay. I've tried to represent a cylindrical vessel. What is 7? What is 7?
Radius.
The radius of the cylindrical vessel. 7 is the radius of the cylindrical vessel. What is 14?
Height.
Height of what?
What?
Height of the water. And what is 21?
Height of the cylinder.
Height of the vessel.
cylinder.
The height of the cylinder or the height of the vessel. So 7 is the radius because I've marked from here to here is 7. Okay, radius is equal to 7 centimeter. Height of water is 14 centimeters, and the height of the vessel or the height of the container, whatever, height of the container is 21 centimeter. Now you can find two things here. The capacity of the vessel. What is the capacity of the vessel? The capacity of the vessel. Okay, it's a cylindrical vessel. So the capacity of the vessel is pi r square h. So pi into 7 square into height is 21. When you take h as 21, you're finding the capacity of the vessel. How will you find the volume of water? Volume of water in the vessel. We know that, water assumes the shape of the container. Okay. Water assumes the shape of the container. So water in the container also will be cylindrical. So the volume of the water is cylindrical. So pi r square h only. Volume of the water is also pi r square h because it's inside a cylindrical vessel. So it assumes that shape. So water is also inside cylindrical. So pi r square h. So pi, 22/7 into r is the same 7 square into height is what?
14.
What is height, children? I've got the answer from the offline students. What's the height of the water?
14.
14 centimeter.
14. So when you take the height as 14, you find the volume of the water. When you take the height as 21, you find the capacity of the vessel. Pi r square h only. Vessel is cylindrical, pi r square h. Water is also cylindrical, pi r square h. If you take the height of the water, you're finding the volume of the water. If you take the height of the vessel, you're finding the capacity of the vessel or the volume of the vessel, which is capacity is how much liquid the vessel can hold. Is this difference clear?
Yes, ma'am.
Is this understood, children?
Yes, ma'am.
Now let me tell you one more thing. Now supposing I drop something spherical inside this. Okay, I drop something spherical inside this. So the water level increases. It becomes now it rises till here. Okay, so this one is say 16 centimeter. Okay, now I drop something into the liquid, so the water level increases. The water level comes now here to this point, which measures 16 centimeters. Now you can find the volume of the solid which is dropped. the volume of the solid which is dropped. See, when you drop the solid inside the vessel, the solid has a different shape, but its volume will be equal to, the value of the volume will be equal to pi r square h, where pi is 22/7, r is 7 into h is 2. Because why did the height of the water increase by 2 centimeters? Because the object was dropped in. So that height 2 relates to the solid. See, the water was quietly standing at 14. Why did the water level increase to 16? Because you dropped something in it. You might have even dropped an irregular object in it. Whatever it is, whether it's a regular or irregular, meaning some shape, maybe using clay, you just crumpled it and you dropped it inside. Whatever it is, the water level increases. Why did it increase? Because you dropped something inside the water. If you didn't drop anything, it will stand at 14. You dropped something. Because of that, the height becomes 16. What is the difference in height? 2. The 2 increases because of this object. So pi r square into 2 will be the volume of this object. Will be the volume of this object. Right, make a note of this, children, all of you. I'll just write. So this is one thing. This is one thing. This is the second thing. And then volume of the object. You should understand how we get volume of object. Volume of the object is equal to pi r square h3. That is pi into r square, that is 7 square into h3 is 2. Simply I'm differentiating h1, h2, h3 because all the heights are different. No, you should not take the height as 16 centimeter. 16 centimeter is not the height. 2 centimeter, that increases because of the object. So 2 is the height. Yeah.
How we will know it is 2 centimeter, ma'am? It can be a 3.
No, I'm saying that it increases to 16. That's given to you. That is given to you. I am telling you that when I drop an object inside the water level comes to 16. I'm giving you that information. Originally the water was standing at 14, right? And when you drop the object, it is rising up to 16. I'm telling you that. It's an observation. So the increase is 2, right? No, your question is something else?
No, ma'am.
Okay. So 3 things we'll have to write: capacity of the vessel, volume of the water, volume of the object. Don't be in a hurry, write it slowly. You need to understand. So online students from next class, I'll ask you to turn on the camera at regular intervals. You can keep it turned off otherwise. But when I ask you, like how I asked you to raise your hand, when I ask you to turn on your camera, you must do it instantly. So this class, since I didn't give you that instruction, I'm not asking you to do that. From next class, I might ask you about 10 times in the 2-hour session. So every time I ask you to turn on your camera, you must do it instantly. Yeah, is this done, children? Yeah.
Yes, ma'am.
Yes, ma'am.
All right, children, fine. Is this very clear, all of you?
Yes.
Very clear? So pi r square, radius will be the same. So you have 3 different heights here. The total height 21, that will be the capacity of the vessel. If you take height of the water, that's the volume of the water. If you take the 2 centimeters, that will give you the volume of the object which is dropped in the water. Volume of the object you will get. Pi r, you will say what object is not cylindrical, then why you're using cylinder formula? It's not cylindrical, but because you drop the object, only the height of the water increases by 2 centimeters. So that volume, see, like this volume, this is 14, this 16. This volume of water is equal to the volume of this object. So this volume of the water will be, the height is 2 centimeters. So pi r square, that is radius is 7. So pi into 7 into 7 into 2 will give you the volume of this amount of water, which is equal to the volume of this object. Okay, so now I think if you understand this, then this question is easy to answer. So see here. A metallic sphere, spherical, okay, sphere of radius. So sphere, for a sphere, one thing is enough, radius is enough. Okay, what's the height of the sphere? What is the height of the sphere? What's the height of the sphere? Okay, tell me what's the answer? 42. 42 centimeters. The height of the sphere is 42 because the radius is 21. The radius is 21. What is the height? From here to here is the height, which is the diameter. Diameter 42. 42. The height of the sphere is equal to twice the radius. I told you in the introduction class. The height of the sphere is a diameter. So if radius is 21, the diameter will be 42, which is the height of the sphere. Tell me, this is a hemisphere. This is a hemisphere. Okay, this one says 10 centimeters. What is the height of the hemisphere?
10 centimeters.
Radius is 10 centimeter for hemisphere. What is the height of the hemisphere?
10 centimeters.
10, not 20. Huh? Raja is not following. What's the height of the hemisphere? 10. In a hemisphere, the radius is equal to the height. In a hemisphere, the radius and the height will be the same. In a hemisphere, the radius is equal to the height. In a sphere, if the radius is 21, if the radius is r, the height is 2r. Is that understood, children? Online students?
Yes, ma'am.
Yes, ma'am.
Very good. All right. So now a metallic sphere of radius 21 centimeters is dropped into a cylindrical vessel which is partly filled with water. Because if it is completely filled with water, the water will overflow. If the vessel is completely filled with water and you drop the sphere, water will overflow. That's why they are given it's partly filled with water. So that means when you drop the object, maybe the water has not overflown. Doesn't pour out of the vessel. The diameter of the vessel is 1.68 meters. Okay, diameter is given. If the sphere is completely submerged, find by how much the surface of the water will rise. Let's just make a diagram out of this information. See how my diagram is going. It's a cylindrical, children. I'll just draw it like this. It is cylindrical only. Okay. It's filled with water. It's filled with water. Okay. So this is the height of the water. It's completely submerged. Okay. This is the sphere. This is the increase in the water. This one. Okay. It was here. Now this is the increase. It comes to this point. After the sphere is dropped, say it comes to this point. Now what is the radius? The radius is 21. The radius of the sphere is 21. The diameter of the vessel is 1.68 meters. Diameter, is it meter? This meter only. No, I just thought of the mistake. Diameter is 1.68 meters. So diameter is 1.68 into 100 centimeters. So it is 168 centimeters. So the radius will be 168 by 2. 84 centimeters is the radius. So from here to here, this one, the radius is 84 centimeters. Because it's in meter, everything should be in the same unit. So we'll convert to the smaller unit. Centimeter, meter, the smaller unit is meter. So we'll convert it to meter. Oh, sorry. Centimeter, meter, the smaller unit is centimeter. So we'll convert everything to centimeter. 1.68 meters into 100, 168 centimeter, divide by 2, because that's a diameter, radius, divide by 2, 84. That's the diameter of that's the radius of the vessel. If the sphere is completely submerged, find by how much the surface of the water will rise. All right. So the rise, what will be the rise? What will be
The volume of the sphere.
very good. The rise will be equal to the volume of the sphere. So the volume of water increased in the cylinder. Is equal to the volume of the sphere. Is equal to the volume of the sphere. See here, this I'll tell you one minute. This volume of water is equal to the volume of the sphere, is equal to volume of sphere. Very good, Arjun. So this volume of water, see, because it was here, originally the water level is here. Because you drop the sphere, it comes to this height. So this is the increase. This portion is the increase in volume. This volume of water is equal to the volume of the sphere. That's what volume of water increased in the cylinder is the volume of the sphere. The two volumes will be the same. What is the volume of the sphere? 4 by 3 pi r cubed. And here pi r square h. Cylinder, no? So pi r square h. Now we'll have to differentiate. H is only one h. So we'll make this R1 and make this R2. So pi and pi will get cancelled on both the sides. Okay, let me continue here. R1 is what? Be careful. Radius of the cylinder. 84. So 84 into 84 into H. You can see your R1 square into H. H is what we don't know. That increase in height we don't know. Into H is equal to 4 by 3 into R2 square. What's the radius of the sphere? 21. So 21 into 20. That's all. See. So every time, see in this word problem also, that equation in words is very important. If you write that equation in words, it's very easy. Then you substitute the formula under that and you can get the answer easily.
It won't be R cube.
R cube. Oh, 20. Yeah. Into 21. Yes, sorry. Thank you. Yeah. 4 by 3 pi R cubed. 21 into 21 into 21. Yes. I'll not clear the slide. You can see it here. Please work, children. It's the same thing. I'll try to work all this here also. Meaning I'll try to draw the figure here. Or I'll show you the figure. Write down the question in the figure. The answer is worked in the slide. You can take down the figure from this. Please make a note of the figure. It's very important. The figure speaks the answer. If you see this figure, you can understand the answer.
Completed, ma'am.
Completed, ma'am.
Taking the figure. One, yeah, you can see the answer from here. The answer is here.
Completed, ma'am.
Yeah. See, so differentiated using R and R1 children. So you can do anything, R1, R2, whatever. So I've used R for the sphere and R1 for the cylinder. Radius is 0.84 into 100, so 84 centimeter. You can write it in detail like what I told you there, no? Diameter is 1.68 meters. That is not into 100, so 1.6. You can take down this for the radius part. For radius, you can just take down this one. How we get 84? Or your own method, whatever you've done. Diameter is 1.68, so into 100 and then by 2. Please write it in detail. I asked you to take the figure also. The figure is very important. If you have the figure in your book, all right. So the C equation is very important. Increase in the volume of the water is equal to the volume of the sphere. This volume of water, this volume of water is equal to the volume of the sphere. So to find this volume of water, it is pi r square h. This h is what you'll have to find. This height we'll have to find. Yeah, write down this question. All right, I'll show you the answer. I think you can understand, help yourself. You may go through the answer and then work, or you can write it and then go through. That's your choice. But I'm not explaining this. You have to help yourself. You'll have to work all this, children. See, I've not shown the working. See, you should work this 2 pi RH. You should substitute 2 pi RH. So that is 2 into 22 by 7. You should not write is equal to 1320 like this. And now you start writing. I'll work it here.
Completed, ma'am.
Yeah. Understood, Danya? Any questions?
Understood, ma'am. No doubts.
Understood? Boys behind. Done, boys? Yeah, those are the homework. I'll explain this in the next class. Send this in the group. Yeah. Yeah, so this answer, I've taken a picture of this one and shared it in the group, children. Finish it in your classwork. By the next class, I'll explain this in the next class. It's time. All right, children. So that's it for today's session. Thank you so much. Online students may leave the call.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Good, children. Good night.